register, we can imagine a shift register to be like this with some data bits inside it. Data bits will be in the form of zeros and ones. Shift register can be 8-bit, 16-bit, 32-bit and so on. But the basic working principle will remain same. As its name suggests that the shift registers are shifting data. This means that data or the data bits inside the shift register will be shifted to the right side or the left side. For example, if we are using right side shifting register, this means that the data bits will be shifted to the right side by 1 bit each time shifting instruction is executed. One thing I need to discuss here is that we can shift a single bit or 2 or 3 bits at once. It depends on our programming requirements. Similar way, if we are using left shifting data register, the data bits inside the shift register will be shifted to the left side each time the shift instruction is executed. Another type of the shift register is the rotate data shift register. In this register, the last data bit will be shifted to the first place in the shift register and all other data bits will be shifted one place ahead. So we can imagine the bits are being rotated in the shift register each time instruction is executed. The shift register has some data inside it and it is shifted or rotated across the register each time shift instruction is triggered. Now let's see an example so that we can understand how to use shift register to execute complicated tasks in the easier way. Here we have a bottle filler with 8 filling nozzles, and this filler will be filling 2 different sized bottles which are 250 ml and 500 ml. For this filling task, we have to track the bottle size under each filling nozzle accurately. We can imagine these 8 filling valves as the 8 data bits of the shift register, and this data register has the data bits inside it in the form of zeros and ones corresponding to the size of the bottle under each filling nozzle. Data bit 1 indicates 500 ml bottle and data bit 0 indicates 250 ml bottle under the filling nozzle. Next thing is the bottle height sensor, which is either on or off, means it is detecting 500 ml bottle as it turns on and it gives 1. For small 250 ml bottle, it remains off and gives 0 data. We also have an index sensor in the conveyor, which is activated once for every rotation of the gear. This sensor indicates the conveyor belt is moved one step forward. We can use this sensor signal as a trigger to shift the data bits across the shift register. Let's see the complete animation and try to understand how the whole concept of shift register is working. As you can see that we have a big 500 ml bottle under the infeed sensor. The height sensor is giving the data 1. As the conveyor moves one step ahead, an index sensor triggers. The data bit 1 is moved to the first place of the data register. Next, 250 ml bottle is under the infeed sensor, which gives the data 0. As the conveyor moved one step ahead and the index sensor triggers, the data bit 0 is moved to the first place of the data register. Similar way, the data bits in the form of zeros and ones are being entered into the data register and shifted forward in the right side each time index conveyor sensor is triggered. In the last, we have 8 bottles of mixed size in the filler, and we can track the location and the size of bottles under each filling nozzle using the data bits we have stored inside the shift register. 0 bit is for the 250 ml and 1 bit is for the 500 ml bottle, as we have discussed earlier. We can use these data bits to control the filling time of each nozzle, so that we can control how much volume we need to fill in each bottle. So now we can fill 500 ml in the big bottle and 250 ml volume in the small bottle. So this is a very basic example to give you guys a concept. How does a shift register works and how we can use shift register to make our life easier while programming.